Welcome to our channel Circuits Analytica. In this video, we will discuss a tutorial on transient analysis of RL circuits in S domain. For the following circuit, find an expression for voltage across 1 ohms resistance for all values of t greater than 0. Initially, switch is at position A for all values of t less than 0 and circuit is in steady state. Current flows through the inductor. Charging current of the inductor is equal to 2 volt divided by 2 ohms, that is equal to 1 ampere, as inductor acts as a short circuit for DC. So during steady state, current flow through the inductor is equal to 1 ampere. At t is equal to 0, position of switch is changed from pole A to pole B. And inductor does not allow sudden changes in current flow. So inductor forces the same current to flow through it. So the circuit can be redrawn as shown here. At t is equal to 0, when switch S is changed from position A to position B, the circuit can be represented as shown. So transform the circuit from time domain to S domain. Inductor of value 2 Henry can be represented as 2S in series with a voltage of value minus 2 volt. So now apply KCL at node P. According to KCL, total incoming current is equal to total outgoing current. All the currents are outgoing. We can write I1 plus I2 plus I3 is equal to 0. So Vs minus 2 divided by 2S plus Vs divided by 1 plus Vs divided by S is equal to 0, where Vs is the voltage across 1 ohms resistance. So the equation can be reduced to 2 plus 2S Vs plus 3Vs is equal to 0. So finally we will get Vs is equal to minus 1 divided by S plus 1.5. So we are asked to find voltage across the resistance. If we take the inverse Laplace transform of V of S, we will get voltage across the 1 ohms resistance V of t. So V of t is equal to Laplace inverse of minus 1 divided by S plus 1.5. So V of t is equal to minus e raised to minus 1.5 t u of t. Thanks for watching Circuits Analytica. Enjoy learning.